Okay, let's get into this. You know how every single spring, the new drivers come out, and the first thing you hear is all this marketing talk about low CG or deep CG.
Oh, yeah, it's everywhere. They treat it like they just invented a new law of physics.
Exactly. But what does that phrase actually mean? I mean, when you're standing on the tee, looking down a fairway, what is it really doing for you?
Well, what's so fascinating is realizing that the center of gravity, or CG, it isn't an optional extra. It's not some premium feature you pay more for.
Right.
It's a fundamental, non-negotiable law of physics. It's just the unavoidable result of how a designer put all the parts together. The metal, the carbon, the glue, you name it.
So, our mission today is to cut through that noise. We want to get to the fundamental mechanics that influence every single shot you hit. We're going past the buzzwords to the
The
physics.
physics that dictates your launch, your spin rate, how stable the club feels.
And ultimately, how forgiving it is.
And we promise you don't need to be an engineer to get this. But you do need to make one really crucial shift in your thinking. You have to abandon the idea that CG is just a single number on a spec sheet. It's about mass, but it's mass in three-dimensional space. It's not about finding one magic dot.
Okay, let's start right there then. If it's not a sticker on the club, what exactly is the center of gravity?
So let's define it clearly. The center of gravity is the single theoretical point where the entire mass of an object can be considered, well, concentrated and balanced.
Like balancing a baseball bat on your finger.
Exactly like that. That perfect invisible spot, that's the CG. It's a conceptual model, which is why you can't see it or touch it.
Which immediately gets rid of one of the biggest myths, right? That the CG is a dot on the club face or some mark printed on the sole.
Right. Those are usually for alignment.
Mm-mm.
The real CG is inside the club head, often just suspended in empty space. And because it's in three dimensions, we have to think about it in three dimensions.
There are three coordinates.
Three critical coordinates. First, you've got the vertical position. Is it high or low? Second is the front to back position. Is it forward, close to the face, or is it rearward, toward the back of the club?
And the third.
And third is the heel to toe position, the lateral dimension.
And this is where the knowledge becomes powerful for you, the listener. Because that 3D perspective should make you question everything. When you hear low CG, you shouldn't just nod along. You should immediately ask, okay, low relative to what? The sole, the middle of the face.
And how far forward or back is it? Because that changes spin completely.
And what about that heel to toe position? That could be why you slice or hook the ball.
Precisely. If a club fitter only talks about, say, low and back, they are missing a third of the entire equation. It's the difference between buying a product and actually understanding a system.
A system that's measurable. So before all the fancy computers and CAD software, how did they even find this invisible point?
They use mechanical balance testing. It's actually really elegant in its simplicity.
So just old school physics.
Old school physics. The basic idea is this. If you can balance an object on a really sharp point, like a pin, the center of gravity has to be somewhere along the vertical line that goes straight up from that point.
Okay, so you balance the club head on its sole, for example, and that gives you one line.
That gives you your first balance plane, yes. Then you'd rotate the club head 90 degrees, balance it again, say, on its toe.
And that gives you a second line. And where they cross inside the head.
That's your true center of gravity. But here's the crucial thing. The spot where the pin is touching the club, that is not the CG. It only tells you the direction the CG is in. The CG itself is almost always deep inside the material.
And why this matters today is because it proves that CG is repeatable and it's not arbitrary. You could have two drivers that look identical but move just 1 gram of weight from the heel to the toe.
And those balance planes fundamentally shift. The club will perform differently.
Now, let's throw a wrench in the works. What about loft? Golf clubs aren't simple blocks.
Loft complicates everything. When you try to balance a driver on its face, the point it balances on is almost always higher than the true CG.
Why is that?
Because the face slopes back.
Right.
So what you're seeing is just a projection of the CG onto that angled surface. The real point is actually lower and deeper inside the head.
So the visual spot on the face is misleading.
Totally misleading. And that's why modern designers rely so heavily on software. They can model the mass distribution down to a fraction of a millimeter without ever needing a physical prototype.
And with materials like carbon fiber, they must have incredible control now, right? They can save weight from the crown and put it anywhere they want.
It's absolute control. You can take 25 grams you save from a paper-thin crown and stick it in a tungsten weight right at the back of the head. That lets you push the CG to places that would be physically impossible with just one material like titanium. It's how they tailor ball flight.
Okay, let's make this more specific. Let's talk about irons first. That seems like a cleaner example of CG at work.
It's a perfect example. The principle in irons is very clear. When you move mass toward the back of the club head, the center of gravity also moves lower.
And why is that?
It's just geometry. The rear parts of an iron, the cavity, are structurally lower. They're closer to the sole. So moving mass back automatically moves it down,
Which explains the difference between a classic blade iron
where the mass is centered high and close to the face,
versus a big game improvement cavity back iron.
where that mass is pushed way back and way down. That lower rearward CG increases the launch angle and makes the club more stable. It's physics helping players with slower swing speeds get the ball in the air.
It's not just forgiveness, it's just smart mass management.
That's all it is.
Okay, now let's pivot to drivers. This is where it gets really complex. We hear all the time, forward CG reduces spin. Why? What's the physics behind that?
This is where we have to talk about something called the vertical gear effect.
Okay.
The CG acts like the main pivot point for the club head during impact. Now, if you hit the ball slightly above that CG line, the ball it slides down the face for a split second. That imparts topspin, which lowers your total backspin.
And if you hit it low on the face,
The opposite happens. The ball flies up the face, which creates more backspin, a lot more.
so moving the CG forward brings that pivot point closer to the ball.
Exactly. You're shortening the lever arm between where you hit the ball and where the club pivots. A shorter lever means the gear effect is less dramatic. And since most golfers hit slightly high on the face, a forward CG maximizes that spin-reducing effect.
So if you're a player with a really high swing speed, you're probably generating too much spin anyway. You want that forward CG to kill some of it for more distance.
That's the ideal player for it.
Yeah.
But if you need help getting the ball up, you want the CG rearward. You get more stability, more launch, but you have to accept the trade-off,
Which is higher spin.
which is higher spin. So neither one is inherently better. They just suit different needs. A forward CG driver is a specialist's tool.
And just to give people a reference point, what's a typical middle-of-the-road CG position in a driver?
We use a general guideline, the 35% guideline.
Oh.
On average, a versatile driver will have its CG located about 35% of the way back from the front of the face to the very back of the head.
So if you go past 40%, you're in a high forgiveness model.
For sure. And if you drop below 30%, you're in a low-spin, specialized model. And remember, CG follows the shape of the head, not just the volume.
Right. Two 460cc drivers can be totally different. One could be deep-faced, one could be shallow and wide.
And that geometry dictates everything. A wide body spreads mass to the perimeter, pushing the CG, while a deep face concentrates it differently. Shape is king.
So we've covered vertical and front to back. Let's talk about the dimension that I feel gets ignored the most. The heel-to-toe CG, the lateral position. Why does this matter so much?
It's huge. It basically governs how easily the club face wants to rotate open or shut during your swing. It's all about directional control.
So it can create a built-in bias.
A huge bias. If you shift the CG just a little bit toward the heel, the heavier toe will naturally lag behind, which helps the face turn over. That promotes a draw.
And the opposite for a fade?
Move it toward the toe, and it becomes harder for the face to close. It resists turning over. That can help someone who hooks the ball, or even create a slight fade bias.
I think of it like a hammer. If the weight is centered, it swings balanced. But if you shift the weight to one side of the hammerhead, that side is going to want to lead the way.
That is a perfect analogy. And that's why draw bias isn't just some marketing gimmick. It's the real result of that lateral CG placement, working together with the club's moment of inertia, or MOI.
Okay, we've mentioned MOI a few times. Let's define that clearly. How does it relate to CG?
MOI is simply the club head's resistance to twisting. It's rotational stability.
So on off-center hits.
Exactly. If you hit the ball dead on the CG, MOI doesn't matter much. But if you hit it out toward the toe, the club wants to twist open. High MOI is the force that fights that twisting.
I see. So the CG is the pivot point.
And MOI is the stability around that pivot point. You want high MOI to lose less ball speed and direction on your mishits. And to get it, designers push weight far away from the CG out to the heel and toe.
So here's the biggest mistake people make. They treat CG in isolation, but it's really the twin of MOI. You can't change one without affecting the other.
You absolutely cannot. If you want an extremely low-spin driver, you have to move the CG forward. That means you're concentrating mass centrally, which by definition lowers your MOI. You sacrifice forgiveness for low spin.
And the opposite is true for a super forgiving driver.
Right. You push the weight back into the perimeter to maximize MOI, but that rearward CG is going to increase your spin. There's always a trade-off.
So after all of this, what's the big takeaway? It sounds like a center of gravity is never inherently good or bad.
That's it, exactly. It is only appropriate or inappropriate for a given golfer, for their swing, their speed, and where they tend to hit the ball in the face.
This has been a really useful deep dive. It feels like the main goal for anyone listening is to just stop thinking in buzzwords.
Absolutely. Abandon the marketing claims, the simple ideas like lowest spin ever.
And instead, adopt a new mental model. You need to think in terms of mass, three-dimensional space, motion, and how that interacts with you, the player.
When you do that, CG stops being some abstract term. It becomes a practical tool for understanding why clubs perform the way they do.
And it helps you find the right one for your game.
And here's a final thought to leave you with based on everything we've talked about. Since the most stable, forgiving drivers often have a rearward CG, which adds spin, and the lowest spin drivers have a forward CG, which lowers forgiveness. The real cutting edge isn't just about chasing the lowest spin number.
So what is it?
It's about investigating how CG interacts with MOI to find your perfect balance. The sweet spot between raw distance and playable consistency. Something to think about next time you're trying to decide if you want to hit it 10 yards farther or just hit 10 more fairways.